All right, so in this video, we're going to talk about the tangential and normal components of the acceleration vector. One of the big things we're going to do is we're going to actually decompose this vector, this acceleration vector. So we've got our curve C, and we've got our acceleration vector coming off of it. So now, from this point, I know that I can have a unit tangent that looks something like this. And from there, I could also have a unit normal that looks something like this. Now, to decompose the acceleration vector, we're actually going to use vector addition and the parallelogram law that we talked about much earlier in the course. So to do that, I'm going to extend out my unit tangent. I'll use the dashed line there, and I'll extend out my unit normal like this. Again, that's letting us create this parallelogram here, which then we can use to add some vectors together to come up with our acceleration vector. Now, we've extended some vectors. We've taken the unit tangent, which has a magnitude of 1, and we've extended it, so we want to multiply it by the appropriate scalar. The scalar that I'm going to use is going to be a sub t. So a sub t times the unit tangent. So that a sub t, that's going to be a scalar. Similar to the unit normal, I've extended it, so I need to multiply it by the appropriate length, and so I'll use a sub n for that scalar multiplied by the unit normal. Now, what we know from earlier is that this vector here plus this vector here is going to give us vector A. So that is us decomposing it. So the acceleration vector is going to be a sub t times the unit tangent plus a sub n times the unit normal. Now, that's all well and good. We know what the unit tangent is. We know what the unit normal is. Now we just need to study what a sub t and a sub n are in terms of scalars. So to get this thing started, what I'm going to add to the picture now is an angle. This angle right here, we're going to call angle theta. All right? So now, if we focus on angle theta, and we focus on this triangle right here, then I can see that sine of theta is going to equal this over this. So this right here over this. Now, what is this? Well, this is the same thing as this right here. And so what is the length of this? Well, the length of it is actually the scalar a sub n, right? This has a magnitude of 1, and we've lengthened it to an a sub n distance. So this right here is a distance of a sub n. So a sub n divided by this right here. Now, I don't want to put a down. Remember, I want to quantify it because it's going to be sine of this ratio. So that's going to be the magnitude of a. All right? So then from there, a sub n is going to be the magnitude of a sine theta. I just multiplied it to the other side. And now I'm also going to go ahead and multiply this thing by the magnitude of v over the magnitude of v. Now, it's perfectly legal, but it might seem a little bit random. But the randomness actually isn't as random as you might think. This is actually a formula that we've seen before. Now, it's in a different order, but it's all multiplied together, so it doesn't matter. The magnitude v, magnitude a sine theta, that's actually the magnitude of the cross product. So a sub n is going to be the magnitude of v cross a as such, still over the magnitude of v. And again, that's one of those that we talked about, an angle between two vectors in the last chapter, and so we're just applying that formula again. So there's what a sub n is. Now, to figure out what a sub t is, we're going to use that same picture, and we're going to look at cosine theta. So cosine would be this guy right here over this, and as we discussed, this would now be a sub t, excuse me, and then over the magnitude of a. Applying the same logic as before, our a sub t now would equal the magnitude a cosine theta, and I will again multiply by the magnitude of v over the magnitude of v. And this one now is no longer that cross product, but instead it's the dot product. So that's going to give us now a sub t equals v dot a divided by magnitude of v. So there is now what a sub t is. And remember, both of these are just constants. Both of them are just constants that we would then use to multiply into these vectors to decompose the acceleration vector.